Today's lesson is 2.4, solving equations with variables on both sides. In order to solve an equation with variables on both sides, we have to first make sure that on each side of the equal sign, the expressions are simplified. And what we mean by that is we're going to look to see if we can use our distributive property. So our distributive property is when we have a number connected to a parentheses by multiplication. And what we want to do in this case is we distribute that 5 to both the 2x and the 4 by multiplication. So 5 times 2x would be 10x, and then 5 times 4 would be 20. That's what we mean by the distributive property. And then the next thing we look for is we look to combine like terms as long as they're on the same side of the equal sign. So when we're talking about like terms, we've talked about that before. 10x plus 5x minus 8 plus 2. 10x and 5x are like terms because they both have the variable x. So it's like saying I have 10 xylophones plus 5 xylophones. I now have 15 xylophones. And then numbers without variables are called constants, and those are also like terms. So if you owe someone $8 and you pay them back 2, you still owe them 6. So that's what we mean by combined like terms. After you simplify both sides of the equal sign, we are going to treat it just like we did the other day. We're going to use a property of equality to get all of our variables on one side of the equation. So what we do to one side of the equation, we have to do to the other. And the way we do that is we use the inverse operations. So for example 1a, we have 8 plus 5c equals 7c minus 2. So the first thing I want to do is I want to look on the left-hand side of that equal sign, and I want to say, do I have something to distribute? And I don't. And I'm also going to look on the right-hand side, and I don't have anything to distribute. I'm also going to look at the left-hand side and I'm going to say, do I have anything I can combine? Do I have any like terms? Are 8 and 5c like terms? They are not. Likewise, on the right-hand side, 7c and a negative 2 are not like terms. So I have nothing to simplify on each side, so I'm ready to move all of my variables to one side of the equal sign. So I'm going to choose to move my 5c over with my 7c, and the way we do that is we use inverse operations. So right now the 5c is connected to the 8 by addition. So the inverse of addition would be to subtract 5c. But if I subtract 5c from the left, I also have to subtract 5c from the right. And then we're actually going to do that math. So I have 5c minus 5c is going to cancel out, and I'm left with 8 on that side. I bring down my equal sign. 7c minus 5c is 2c, and I bring down the negative 2. And then this should look familiar because this should look like a two-step equation. My c is now on the right. It's being multiplied by 2 and also subtracted by 2. So remember we talked about working those order of operations in reverse order. So I'm going to undo my subtraction first with addition. But what I do to one side, I have to do to both sides to keep my equation balanced. 8 plus 2 is 10. We bring down the equal sign and we bring down the 2c. And then that 2 is connected to the c by multiplication, and our inverse of multiplication would be division. And so we're going to divide both sides by 2 in order to isolate c, and we get c is equal to 5. So 5 is our solution. That means 5 makes this equation true. So if I were to substitute that back in, so let's just look at this real quick. 8 plus 5c equals 7c minus 2. I now know that c is 5. So if I substitute 5 in for c, this should make a true equation. 5 times 5 is 25. 8 plus 25 is going to give me 33. That means the other side should also be equal to 33. 7 times 5 is 35. 35 minus 2 is 33. It made our equation true, so we know our answer is correct. Example B. Same thing. We're going to look. Do I have anything to distribute on the left? No. Are any of those like terms? No. 9f and negative 6 are not like terms. On the right-hand side, do I have anything to distribute? No. Are those like terms? No. And so now I'm ready to move my variables to one side of the equal sign. I'm going to choose to move my 3f over to the left. So in order to get rid of a positive 3f, I'm going to do the opposite, which is to subtract. 3f minus 3f is going to cancel out. Just like if you had 3 feathers and someone took those 3 feathers away. Why we have feathers, I don't know. But anyway, 3 feathers minus 3 feathers, no more feathers, they're gone. 9f minus 3f will give me 6f. I bring down my minus 6, I bring down my equal sign, and I'm just left with 7 on the right. This should look familiar. It's a two-step equation. Right now, f is being multiplied by 6 and subtracted by 6. So we're going to work those order of operations in reverse order. So I'm going to undo subtraction with addition, but what I do to one side, I have to do to the other. Negative 6 plus 6 cancels. I bring down my 6f. I bring down my equal sign, and I now bring down my 13. My last step would be to undo the multiplication, 6 times f. I undo multiplication with division. And you will see that obviously 6 does not go evenly into 13. You are allowed to leave your answers as improper fractions as long as they do not reduce. Meaning, is there a number that both 13 and 6 are divisible by? And there is not. So you may leave that as 13/6. I know in middle school they were probably used to you saying, okay, 6 goes into 13 twice. That will give me 12, which means there's 1 left over. 2 1/6 isn't an incorrect answer, but in algebra we typically leave our answers as improper fractions. Okay, for example 1c, we're going to include some rational numbers. So one thing we need to talk about is that first part of this equation, x over 2. If you don't see a coefficient in front of x, it is understood to be 1. And so that is really 1x over 2. So if it's easier for you to look at this, this is the same as 1/2 x plus 1. And then that's equal to 1/4 x minus 6. And then we're going to do the same thing. We always look to see if we can simplify the left-hand side or the right-hand side. On the left-hand side, we cannot distribute, and they're also not like terms. On the right-hand side, there's nothing to distribute, and there are no like terms. So we're ready to move our variables to either the left or the right-hand side of this equation. I'm going to move the 1/4 x to the left. So right now, my 1/4 x is positive, so I'm going to subtract it. 1/4 x minus 1/4 x cancels out. And then I do have to remember how to subtract fractions. So I'm going to go off to the left-hand side. Right now, we are taking 1/2 minus 1/4. To subtract fractions, we have to have a common denominator. So I think about 2 and 4. If I count by 2s and I count by 4s, what number do they have in common first? They have a 4 in common first. So notice my fraction of 1/4 gets to stay the same, but my 1/2, my denominator needs to become a 4, and so I have to ask myself, what do I multiply 2 by to get 4? Well, I multiply it by 2, so I also have to multiply the top by 2. So this becomes 2/4, and 2/4 minus 1/4 would be 1/4. And that makes sense. If you have half of a dollar, so you have 50 cents, minus a quarter of a dollar, 25 cents. 50 cents minus 25 cents is 25 cents, so you still have a quarter left, or 1/4. So we have 1/4 x plus 1. We're going to bring down the equal sign, and we're also going to bring down the -6. And then we have a two-step problem. I see that x is being multiplied by a fourth, and we're also adding 1, but we're going to use inverse operations in reverse order, so we're going to undo subtraction first, but what I do to one side, I have to do to the other. 1 minus 1 cancels out. I bring down my 1/4 x, my equal sign, and then remember -6 minus 1. You borrow $6 from someone, you borrow one more, you now owe them $7. And then our 1/4 is connected to x by multiplication. The inverse of multiplication is division. So I'm going to divide by 1/4. Keep in mind, when we divide by fractions, we have to remember one simple thing when we're dividing by fractions. So if I have -7 divided by 1/4, remember all whole numbers are over 1, but division is the same thing as multiplying by the reciprocal. So I always keep my first number the same, but division really means to multiply by the reciprocal, meaning we flip the second fraction over. So I really multiply by 4/1, and we multiply fractions straight across, so I get 28 over 1, because 7 times 4 is 28, and 1 times 1 is 1. A negative times a positive is a negative, and so I'm left with -28. -28 as a solution. So -28 would make that equation true. For example 2a, we are solving each equation using inverse operations. So for example A, we have to distribute the 1/3 first. We always look to distribute first and then combine like terms. So we're going to distribute a 1/3 by multiplication to 18 and 12q. So we have 1/3 times 18. So we're going to take 1/3 times 18, which is over 1. We know that 3 goes into 18 a total of 6 times. And so we now have 6 times 1, which is 6, and 1 times 1, which is 1. And so we just get 6. Then we also have to take 1/3 times 12q. So we're going to take 1/3 times 12, which is also over 1. And we know that 3 goes into 12 a total of 4 times. So we have 1 times 4, which is 4, and 1 times 1, which is 1. So we get 4 over 1, which is just 4. So we have 6 plus 4q. We bring down the equal sign, and then we also have to distribute the 6 on the other side. So we have 6 times 2q and 6 times -7. 6 times 2q is going to give us 12q. 6 times -7 is -42. And then we look to see if we can combine like terms on the left or the right. There are no like terms on the left, and there are no like terms on the right, so I'm ready to move my q's to one side. I'm going to choose to move my 4q over to the other side by subtracting. What I do to one side, I have to do to the other to keep the equation balanced. I know that 4q minus 4q cancels, so we're left with 6 equals 8q minus 42. We now have a two-step equation where we're working those order of operations in reverse order. So I'm going to undo subtraction first with addition. And what I do to one side, I have to do to both to keep the equation balanced. 6 plus 42 gives me 48. I bring down my equal sign and my 8q. And last but not least, I undo the multiplication with division. So the inverse of multiplying by 8 would be to divide by 8. Q is now isolated or by itself, and 48 divided by 8 is 6. So Q is equal to 6. This means my equation has a solution of 6. 6 will make that equation true. And our last example is example B, 2b. We first have to distribute a 6 to both the 3r and a -4. Remember, this is connected by multiplication. So 6 times 3r is going to give me 18r. 6 times -4 is -24. I bring down my equal sign, and now I have to multiply by 3/8. So I'm going to show my work up top. 3/8 times 46, and 46 is over 1. 8 and 46 are both divisible by 2, so I'm going to divide them by 2. So I get 23 and 4. Then I can multiply straight across. 3 times 23 is 69. 4 times 1 is 4, so I'm left with 69/4 R. And then I have 3/8 times 8, which is going to be 3. If I take 3/8 times 8, which is over 1, if you notice, both of my 8s are going to cancel out to become 1s, so I'm just left with 3 over 1. Then I'm going to look to see if I can combine like terms on either the left or the right, and I cannot. So I am ready to move my r's to either the left or the right. I'm going to choose to move my 69/4 to the left by subtracting 69/4 r from both sides. When we are subtracting fractions, we have to have a common denominator. So if I'm finding a common denominator between 18r and 69/4 r, I know my 18 is over 1. My common denominator is going to be 4. That means my 69/4 gets to stay the exact same, but my 18 over 1, in order to create a denominator of 4, I had to multiply the denominator by 4, which means I have to multiply the numerator by 4 so that we keep an equivalent fraction. And if I multiply 18 by 4, we're going to end up with 72. Now I can subtract. 72/4 minus 69/4 is going to give me a total of 3/4. So I have 3/4 r. So I'm left with 3/4 r minus 24 equals 3. I now have a two-step equation. We're still going to use those order of operations in reverse order, and we're going to use the inverse operation. So I'm going to undo subtraction with addition, and what I do to one side, I have to do to the other. So I'm left with 3/4 r equals 27. And my last step is to undo that multiplication. The 3/4 is connected by multiplication. The inverse of multiplication is division. So I have to divide 27 by 3/4. Remember, when we are dividing, we always have to write down the top number first, or our numerator first. So I'm taking 27, which is over 1, divided by 3/4. And when we divide fractions, we really multiply by the reciprocal. So I keep my first fraction the same, but I end up multiplying, so I change my division to multiplication, by the reciprocal, which means I have to flip that fraction over. I am going to choose to cross cancel because 27 and 3 are both divisible by 3. 3 divided by 3 is 1, and 27 divided by 3 is 9. And now I can multiply straight across. 9 times 4 is 36. 1 times 1 is 1. So we are left with 36 for r. This means the solution to this equation is r equals 36.